So good afternoon, everyone. Welcome to the last full afternoon of ESIP. Last full session, right? We made it. And as a special treat, not only do we have swag for you, but no homework in this session. So we're not going to ask you to do math or anything heavy like that. So this is intended to be a little bit more lighthearted and fun. So hopefully you come out of this with a little bit of information, have a good time, get some nice information related stuff out of it. So enjoy. My name is Inger Kittle. I work for the NESDIS Office of Common Services as a data implementation lead. My other NESDIS co-host is Angela Brown, and joining us from ESDIS is Chris Daracha. So the three of us together put together this session, but we also have a host of other speakers and panelists that will be joining us to discuss the differences and similarities between NESDIS and ESDIS. So we'll just walk really quickly through the agenda and a couple of housekeeping items. I'll turn it over to Chris for some remarks, and then we'll go right into our presentations. So here's our items. Just like I said, what we're going to do, our presentation, we'll have a Slido quiz for some of our bigger giveaway items that we brought over here. Like, ooh, ah, yeah, yes. Thank you. Angela went to a lot of trouble to get us these things, so got to show appropriate awe. Also, we do have a Slido quiz and a Q&A section online. So if you have any questions as the sessions come up, the Q&R code is there, but you can also just go to slido.com and type in verses and questions there. Well, John, you guys already took the NESDIS one, so we had to have something. All right. Also, as a little reminder, this year's ESIP theme is Bridging Divides, Data, Technology, and Community. You know how you don't bridge divides? Jimmy? But we were kind enough to bring NOAA and NASA themed items from our shared programs. So please enjoy the community we are trying to build here. And again, a reminder of the Slido quiz. All right, and now I'll turn it over to Chris for his remarks.
I don't think I have any remarks.
Fair enough. All right. So then we go from that to, let's see. All right, I'm just going to have the speakers introduce themselves as they come up.
Okay, good afternoon, everyone. I'm Gian Villamil Otero. I'm a physical scientist. I work for, obviously, NESDIS, as you can see from the NESDIS overview slide. But more specifically, I work for the Office of Common Services, Product Management Division, Product Implementation Branch. So pretty much my role is helping scientists transition their algorithms from research to operations and make that data available to the users. But today, my presentation is going to be more about what NESDIS does as a whole. So I'm just going to, for those of you that are part of NESDIS, or most likely this is going to be old news, and you must know this by heart. But a lot of people here may not be familiar with NESDIS. So bear with me for around 10 minutes while we get to through the slides. But I'll make them interesting. So the mission of NESDIS. NESDIS operates the nation's weather satellites 24/7. We want to make sure that those satellites are up and running so that we can provide data and imagery for creating environmental data records, to be able to give that data to the users, such as the National Weather Service, other partners, commercial sectors, so that they can use that data to either forecast or do research or whatever they want to do with that data. We we want to make sure that we're providing that data to as most people as possible. And a part of NESDIS, which you might know, is NCEI. And they're hold the most comprehensive archives of environmental data on Earth. And I have a highlight there on the lower left corner that around 90% of the data used in the weather forecast models come from satellites. And I don't want to people, when they hear NESDIS, automatically they think of satellites, most likely because they hear that 90% of the data using weather forecast models come from satellites. But NESDIS also deals with other in situ observations, data from ships, data from other sensors that are not specifically in the space. So a quick overview of the different programs and offices. We have the Office of Low Earth Orbit Observation, or LEO, and some of the missions that they are supporting, which you might know and have heard before, is the JPSS and the NEON missions. Then we also have the Office of Geostationary Earth Orbit Observations, or GEO. And again, some missions that you might have heard about are the GOES-R and the GEO-XO. We also have a space weather office, and some of the missions that you may have heard before. I'm just highlighting some of the main missions that they're working on that you may have heard about, just so that you know, oh, that's the office that they're associated with. It's SWIFO and Space Weather next. Then we have the Office of Common Services. That's where Inger and I belong to. And we, as the name implies, we try to provide those enterprise technologies and solutions so that satellite ground systems and other data archives, that we are able to provide that information to users so that they can make informed decisions and enable innovative science. So we also deal a lot with scientists. Another office that is part of NESDIS is the Office of System Services Architecture and Engineering, or SAE, and they provide a systematic approach to requirements, satellite architecture planning, and system engineering. So they're the pretty much the ones that provide that, how that needs to be built, and provides those requirements. A little bit more on the governance of things and making sure that everything is on the up and up is the International Interagency Affairs Division, that they develop the strategic and sustained partnerships that enables us in NESDIS to meet our goals. And then we also have the NESDIS Office of the Assistant Chief Information Officers for Satellites, or ACIO. The S for satellites, which are responsible for the cybersecurity policy and IT enterprise architecture across NOAA. And they serve as the authorizing official for anything IT related within NESDIS. Okay, moving to the last couple of offices, and this one are more focused on operations, products, and data services. We have the Office of Satellite and Product Operations, or OSPO. They collect, process, and distribute the environmental satellite data. And they're the ones, remember when I mentioned 24/7, they are the 24/7 component of this. Without them, any data gaps would be severely felt. So OSPO is a really important part of NESDIS. And none of this would be possible if we didn't have scientists. So the Center for Satellite Applications and Research, or STAR, is the science arm. So they decode, transform the data from satellites into an understandable, accessible, and translatable format. So they are also very important. And last but not least, that data has to go somewhere to keep it archived, and this is where the National Centers for Environmental Information goes. But they not only do archive, they also do research and monitor the environment. So it's really great, all the work that NESDIS does in multiple aspects of the government and the weather and climate and data. Okay, so moving now to how NESDIS deals with data, because data comes from satellites, comes from many different places, and we also collaborate with a lot of people. So our acquisition strategy just boils down to three things: build, collaborate, and buy. So we design, launch, operates NOAA's core proprietary satellite fleets to make sure that the data is continuous. We collaborate because we have partners, international partners like UMESAT, that we collaborate to make sure that we're also able to use their data. And we also buy. We have a commercial data program, or CDP. And this is where Spire, Planet IQ, Tomorrow IO comes into play. We want to make sure that we're leveraging also the commercial sector to be able to expand the science that we do. More talk about the CDP. Is a value added. Right now, we have a very big mission with the operational radio occultation, or RO. We did Spire and Planet IQ. We're working with Cosmic 2 data to make sure that we're getting that data. And we also have the microwave sounder, Tomorrow IO. For those of you that don't know what Tomorrow IO, but might know Tropics, Tomorrow IO is the continuity of Tropics. It's important to make sure to understand tropical cyclones and measurements. This is something that you may have all heard. Again, we under OCS and NESDIS, we want to make sure that we are providing enterprise tools for people to use. And we want to do it in a modernized way. And this is where the NESDIS Common Cloud Framework comes into play. This was launched to serve as a single, loosely coupled, scalable cloud environment because we've noticed that we have data all over the place. Scientists getting data from different places. So the NESDIS Common Cloud Framework, or NCCF, came as a realization of that. Let's put all the data together in one place and have the scientists work next to the data rather than get that data. So scientists work in the NCCF, the data is in the NCCF, operations is in the NCCF. So everything can just move faster from research to operations because everything is in the NCCF. And one thing that we also do, and this is more now related to the work that I in our branch do, is the life cycle, product life cycle and processes. So we have all the way from requirements all the way to retirement. We have different readiness levels based on where an algorithm or a scientific application is. You can be doing innovation, something that is groundbreaking, and then that innovation is a new capability. If it has value and it's proved to go into operations, then we move into readiness level 6 through 8, which is development, testing, and preparing that scientific application for operations. And lastly, it ends in operations, right? Readiness level 9, that's the highest you can go. That is maintenance, deployment, and running the application in operations. Then when the products are no longer needed, then we go through the requirement. We have the different processes to make sure that we can handle that correctly. The product lifecycle within the NCCF, and I hope that the text is not too small. Inside the NCCF, we have a sandbox environment that, as the name implies, that is where science teams and scientific applications can be tested, can be developed. It's a sandbox. You can play in it. The data that is used by these teams, they come through a secure ingest which is our service that gets all the data from across the world or anywhere that we want to make sure that data is used by the teams. We get that through secure ingest, and we make sure it's centrally located. Then we have applications that, as we transition to operations, they run through different environments to make sure that things are okay. We have the development environment. We have the UAT, or user acceptance testing, where users are able to see the output before it gets released into operations to make sure that everything is okay. If the users, and by this case, usually scientists, if they say, hey, my product is not generating the output as I intended, then it goes back to our team to make sure that it does. And lastly, it goes into operations, which it then goes through the dissemination and access test portal to make sure that it's disseminated to all the users. And I just pretty much touched the fifth and sixth bullet points there. But all of this, it's very complicated, and none of this would be possible if we didn't have what we call a cross-functional agile team, because what this means is that we have everyone that is part of that life cycle process, the integrators, science teams, end users, the NCCF implementation team, product owners, everyone meets together to make sure that we're able to react quickly to any changes. There's a change in format that we were not expecting. Well, we meet together and we're able to react quickly. And through this agile workflow and this cross-functional team, we're expected to make this life cycle transition from research to operation faster. So to finish, and what does this all mean is that we do agility at the speed of science. We leverage these methodologies, agile methodologies, the NCCF, to make sure that we can transition faster. We want to make sure that we have data without borders using the FAIR. And we want, since we're in the cloud, we want to make sure that the data is also cloud, not only cloud ready, but AI ready as we move towards AI. Innovation through partnership. I mentioned about CDP. We want to make sure that we're leveraging as much as we can. And we want to make sure that the modernization and everything that we do sets up any mission successes in the future. And that's it for my presentation. Thank you so much.
Good afternoon. I realize I did not put my name on the slide. I am Dean Carter. I am a physical scientist at National Centers for Environmental Information, which, as Gian said, we are NOAA's official repository, both for physical and digital holdings. And that's for all NOAA line offices, not just for NESDIS. And I'll be giving this presentation. And before I proceed, I'd like to give a special shout out to my colleague, Phil Jones, who helped me put the slides together, but he cannot be here at ESIP. Slide, please. Oh, am I controlling the? Okay. As I was preparing the slides, I took a look about how much data we have in the NESDIS archive. The NESDIS archive encompasses NCI both on-prem and in the cloud, and also CLASS, if you're aware of CLASS. I'm not sure what the acronym for CLASS is, but it's about 40 petabytes of data, and about 350 terabytes come in a month. And that's both remote sensing and in situ data across the NOAA's Earth observation systems, and also a lot of external, both domestic and international data sets come in. We provide the data stewardship and the product creation for decision making for a wide swath of sectors, both governmental and private sectors, insurance and things like that. Our director, Decarn, is very big on that type of customer outreach with our products that we create with our data that we store. NCI has, as the NESDIS archive, has some dedicated pipelines of data, like for paleoclimatology and bathymetry are examples, but generally for the wider scientific community, there are two routes to get data into NCI. The one on your left is the public interface is called ATRAC, and it's used to submit automations or large data sets over 50 gigabytes. Again, that require an automation to be set up. Smaller data sets that are non-repeating and less than 50 gigabytes will come in through another route, which is called Sent to NCI, or S2N for short. ATRAC submissions, new submissions are being placed on the NCCF and for archive and dissemination through One Stop and CMR. Sent to NCI is currently being archived on-prem on the archive management system, but that is in the process of being, as we or calling it lifted and shifted into the cloud very shortly. People about timelines, about to get a data submission published into the archive. People often ask that question or maybe even complain about it. It depends. For A-track submissions, there's a systems engineering rigor involved with it because these automations, you have to negotiate with a provider. It's called a submission agreement. If you're familiar with the terminology, you negotiate the file formats, the interfaces between the submitter and NCI and things like that. There's key decision points, readiness reviews, and things like that. So generally about a year or so, but sometimes a data set will have a high priority because of it's NOAA funded or it's high visibility. But it might be longer if it's a non-NOAA submission. S2N generally is within 30 days, so it's a manual process. There's only two people involved. There's a data content manager that preps the package, the metadata, and then there's a data officer, which is the role I fill, that checks the package and publishes it, and then mints the DOI. NCI has a unique role in NOAA is that we are designated as the only agency that can mint data DOIs for all NOAA line offices, and that's stated in the NOAA Data Management Handbook. Reserved DOIs can be requested once NCI has archival control of the data. So what that means is that we have custody of the data. It's not just being promised to us. And we've done a scope assessment against our collecting policy, and we intend to publish the data set. And we can provide guidance to submitters on the minimum criteria for DOIs. And I neglected to put the email, but it's easy to remember, nci.doi.noaa.gov. And lastly, as a policy, NCI will issue DOIs for all new data sets unless the data set already has a DOI from an alternate repository or the new accession belongs to or is intended to be part of a collection that already has a DOI. And this is an overview of NOAA's metadata and catalog services. On the upper left, there's comment, which is the NOAA's metadata and editing tool, and that feeds downstream to Collection Manager that harvests metadata from line office web accessible folders, manages the metadata that was created into comment, validates and scans, and then publishes the metadata to OneStop or Collection Manager web WAFs. So OneStop is the OneStop Inventory Manager will feed the various search engines like data.gov. This is just a quick overview of the archive slice. Gian gave a very good overview of the encompassing overview of NCCF, but this is the archiving slice. On the lower left is NextGen S2N. So that is the successor to the two legacy ingest systems that I described on slide 3. And that is for data producers to submit data to NCI. And data managers will use OS, which is, help me out. Yeah, so thanks. So OS has a workflow for each data set, and there's various buckets that you can see depending on where it is in the process. And then there's an access bucket, and then it populates the catalogs, and then finally it populates a graph bucket, which the final slide is. Utilizes knowledge graphs, which I'm sure many of you are more of an expert on knowledge graphs than I am, but it's a relational database on steroids, I guess, is the best way to describe it. So, and that concludes my portion, and I'll be happy to take questions later. Thanks.
Thank you, Dean. I promise the OS thing won't be on the quiz. All right, Chris, I think that's all for the NESDIS section, so you're up.
Okay. So I'm Chris Tarachka. Remember about a year ago, we had this thing called a furlough? The day before the furlough, they asked me to step into the role of the project manager for ESDIS. Congratulations, Chris. You're the acting PM. By the way, you're also essential. So you're going to spend the entire furlough here. Yeah, I was a little lonely. All right. Yeah. But I talked to a lot of people. I talked to a lot of the DACs, a lot of the folks doing the work. I've learned a lot of things. I'm not real long in the tooth in ESDIS, but I do a lot of listening. Some of the things that I've learned, let's go specifically between ESDIS and NESDIS. We're very complementary. I think we have the same core value. We want to get the data into the hands of the users, no matter who the user is, right? That's you guys, right? We want to make sure the data flows easy to you. I actually read that about 80% of a scientist's time is dedicated to finding the data and reformatting the data to do their science. We got to get better, right? That is the goal I keep giving everybody in ESDIS. Let's make it 75, 60. So another thing I've learned between ESDIS and NESDIS, right? NASA spends a lot of time looking back, a lot of the trend analysis. NESDIS, I believe, spends a lot of time today looking a little forward, right? Pretty different technique. And I can actually prove that by how we correct data. So if we find a mistake in an algorithm, NASA spends a lot of time and reprocesses that entire data flow. I believe you guys make the correction and move forward. You do some reprocessing, but it's not nearly to the degree of what NASA does, right? I'm also going to give you guys a lot of credit. You document the hell out of your changes. We got to do a little bit better at that. Let's see, what else have I learned? Everybody has a view into ESDIS and has a thought of what ESDIS is. I've learned about 60% of that's wrong. And I'm hoping we can get through this pretty quick and we can talk about what your thoughts are and we can correct them. Okay? So we'll go pretty fast. Hold on. We don't have nearly as many of offices as NESDIS, and our slides aren't nearly as dense. We're going to talk about this stuff. Okay, so what is the goal of ESDIS? We have two goals. Capture the data, archive the data, right? Get the data in the user's hands. We also want to put some special sauce in there, right? Standardization, interoperability, that's important, right? In order to work on a project, I think it's really important to find out or learn how you got there. ESDIS, from what I could tell, and I went all the way back to the beginning presentations for ESDIS. ESDIS was formed to support the Terra Aqua Aura TRIM. No one remembers TRIM. We were okay. So ESDIS was formed to support that group of satellites. We did, just like NESDIS does today, we did the mission control, the processing of the data, archiving, distribution. It hasn't really changed. In 2004, we did break off the mission operations, and I suspect that is when we started bringing in more and more data sets. So we kind of outgrew that part of the vision. Pretty soon, we're going to break off the data processing piece. So ESDIS is going to be really focused, hyper-focused, actually, archiving, getting the data into the user's hands. Okay, let's go back in history. There were 7 DACs, there were 11 DACs, there were 12 DACs. We've been all over the map, right? But what was essentially was going on is a new mission came up. We assigned that mission to a DAC. That DAC essentially became a silo for that DAC or for that data, right? So the DACs essentially really, and they do a great job. I'm not knocking the DACs. There are some of the most capable people, scientific people, engineers, sysadmins. They're the best I've actually ever interacted with. But they had these imaginary boundaries where they really focused on how do we make sure that people can use the data in our set, right? Became a silo. But like any old organization, their responsibilities kind of grew out a little bit, right? For instance, if we're doing this kind of data, maybe we could do this kind of thing, this kind of data. Or maybe we could develop a tool to visualize it some more. So there was the natural growth of a DAC. We did data processing from level 0 to about level 3. And we could argue all day long what 3 is versus 4. Let's not go there. We talked about the data discovery. We support an amazing amount of different types of data. And I've learned it today, from mission data, and I heard we actually even do sensor data that's on the ground and everything in between. Now, how do you make a tool that traverses all that? We have enterprise tools. So I don't actually know when this started, but there was a movement. I believe it was called Echo. Does anybody know Echo? So Echo was really brought to help with the discovery of data across the DACs, from what I can tell. Please correct me. Our user community. Traditionally, our user community was only research scientists. That has changed even in the last 9 months. Our user community has gotten really diverse. Let's go all the way to AI bots, right? They are essentially a user community. This is one of my favorite charts. It's my scary chart. This is pretty damn big. In fact, we only do this chart once a year. Our archive is right now, it's about 160 petabytes. Depending on who you ask, depending on what caveats you put in that number, right? It changes. Yes, there's a lot of duplication in there. I get it. Either way, it's big. Our distribution volume is about 600 terabytes a day. We have about 10 million users a year. That does not include Worldview and Gibbs. It probably doesn't include firms either. Is Jenny in the room? I don't see Jenny. That doesn't include firms, does it? Yeah. Yeah, that number's awful low compared to what we actually do serve out. Our average growth rate, I think it's in red because they were talking about NISAR. NISAR isn't as big as we thought it was going to be. That's still pretty big. Okay, what are our stressors? So I bet many of you have heard budgets are questionable these days. When you see a chart like this and you find out that your budget isn't going to increase with the size of your archive, most sane people would probably say, I don't really want that PM job. I'm going to take it as a challenge though, right? So I will say, thanks to the work on ESDIS, our predicted cost for the archive 3 years ago, the actual was half, because they are constantly working at how do we reduce the cost of the archive. One thing that went on like wildfire during the last budget process was, oh my God, we're going to get rid of the archive. And even the bleakest budget thing I saw, archive was covered. The ingest into the archive was covered. you don't have to worry about the archive going away. You might worry about your favorite tool going away because we're going to replace it with something a little bit better. Data access analysis methods, they're changing. Every day we're seeing people doing new things. We're seeing people pull data sets out of the archive that we've never seen before. That tells me that single stream science isn't as popular as it used to be, right? We aren't talking about just a rain over a certain area. Let's come up with a scenario. How about the progression of some disease from birds flying over New York City during COVID, during a rainstorm? That sounds like a pretty hard problem. You're not going to just go to one archive for that or one DAC. Our tools, a little bit fragmented. I watched it this week. All of our tools, I can tell they really only pull data from their archive or their DAC. Some of them are pretty good. They go a little bit further, but really their sweet spot is their DAC. Our systems are a bit siloed, and everybody has their own view of how we're going to handle a standard. Which really comes to, really is the primary goal of the next couple of years. We have an inconsistent user experience. That's what we got to fix. Bring up user experience. Yes. Well, we could level it. Leveling most of the people are actually getting better, right? Yeah. Yeah. We have to do better in supporting the user. And that's where we're going, right? That's what we have to get behind. Okay. There are changes going on at ESDIS today. Many of you have probably seen it. We're working right now to consolidate all of our ingest and archive systems to the cloud. Can you guess how many archive systems we have at ESDIS? All it does is pull the data, put it into the cloud. Well, I'm not even sure I know because I've heard different numbers. The last number I heard was 84. We have 84 systems to put data in the cloud. That's quite a bit. We're working at getting it down to 5, I think. 5. He always has to caveat it. Okay, 5 production, but probably a much more development, right? Again, the goal is with all that diversity in there, they're all doing it a little bit different. That's not helping the user downstream. We talked about this at one of the sessions today. ESDIS was going to go under a tool convergence, which means we picked 5 tools and tried to merge all the other functionality in those 5 tools. We're going to stop that. We're going to actually develop a tool catalog, make it transparent to the users. They can download what they want to download, use what they want to use, but we're also going to use that in 3 tiers. There's a lot of tools we're going to have to maintain. But there's another group that I really want to challenge the open source community and OpenScapes. Let's have the community work on these tools. Right? The difference here is, because I've done this a lot, I've put a lot of systems out in open source. They've all kind of failed. The one thing that we're going to do different here is we're going to fund this OpenScapes to do this. I'm putting money behind it so there's a management, there's an organization, and there's a thoughtful process to propel these into the future. That's kind of what all this says. Okay, SOAR, that's another big consolidation effort. So not each of the DACs, but probably about 5, 6 of the DACs all have their different ways of bringing in suborbital data. Sarah has combined that into one group. So hopefully, pretty soon, we're going to have a very consistent way of how you're going to pull that data down. And we're also going to give you videos of how to format the data before you give it to us. Right? Because right now, the data comes out to us in many, many ways. As this tomorrow. We're our organization is really based on the DAX. We're going to flip that around to how we work. We're going to have a group that does data stewardship. Those are the folks that are really going to be focusing on the archive of the data, long-term data management, preservation, making sure that data can be used long-term. Science enablement. That's one of the big focuses, right? We need to be able to help the users use the data. Enterprise services, that's where all the tools are. From Earth Data Search all the way through CMR and all the other tools that we use. What builds these together is we're also going to have a system engineering pillar, which I keep forgetting to put on this slide. Yeah, that's right. It's the blue line at the bottom. Have I said I have a great group? What is our fundamental commitment? We're going to preserve data, we're going to make it accessible, and we're going to maintain our operational excellence. You got to have principles, right? Accelerating time to science, cross-functional collaboration. So once we kind of solve this problem of being able to traverse through our entire archive, the next goal is let's expand that to the NESDIS archive or all the other archives I've seen today or this week. Standardization and interoperability. We're going to support users where they are, right? You don't have to be a research scientist to use this data. We have a lot of people that do application of the data. We got to support them better. So then my ears are open. How do we make things better? We're going to do questions? I think that's it. Yeah. Thanks.
All right. Thank you, Chris. All right. So we're going to switch gears now, and we're going to get the Slido quiz set up.
The first person that answers the question rises to the top, okay? So in the end, you get to pick from swag based on your number, okay? That's it. You guys ready? What does ESIP stand for? It stands for Earth Science Information Partners. Okay, so Justin is in first place. All right. Next question. What does NESDIS stand for? Someone said it stands for not ESDIS. Okay, AES is in first place. Okay, next question. What percent of NESDIS satellite data is used in weather forecast models? 90%. Sarah is in first place. Next question. What does ESDIS stand for? 73% of you got it right. Who's in first place? Jimmy. Remember, it's a time thing, right? The quicker you answer, the better. What year was ESDIS established? The early 90s, the late 80s, the late 60s, or the early 70s? And the answer is the early 90s. AES is in first place. NESDIS is a NASA program. True or false? False. 96% of you got it right. But who got it right first? Okay, so AES is in first place. Next question. ESDIS data collection is projected to surpass 600 petabytes by 2026, 2028, 2030, 2032. Were you guys paying attention? Take a guess. Take a guess. And the answer, 2030. You guys got it right. Okay, so who's in charge? Who's? Tim. Okay, Tim. Next question. Is CMR used by NESDIS, ESDIS, or both? 85% of you said both, and you are right. Who's in? Okay, Tim. Tim was paying attention. Next question. Is A-Track considered a storage or archive system? Archive. AES, it's in first place. A-Track is used to archive what size data sets? 50 terabyte and over, 50 gigabyte and over, or 50 petabytes and over? Yes, it was. That's where I got the questions from. Okay, AES is in first place. Next question. What does DOI stand for? Digital Object Information, Data Object Identifiers, or Digital Object Identifiers? 87% of you got it right. Digital Object Identifiers. AES, you're rocking. And I think we have a few more questions. Is DOI a NESDIS term, ESDIS term, or both? Both. AES, okay. Somebody was paying attention. Okay. And is that the last? No, 12 and 17. Okay. A few more. Is NCEI the only authoritative body that issues DOIs? Yes or no? The answer is no. Are DOIs only issued for archive data sets? Yes or no? No. 73% of you got it right. And AES is showing off. Next question. If you have a collection ID, do you need a DOI? Yes or no? No. 32% of you got it right. Okay. Two more. Alexis, yay. Okay. Is One Stop a knowledge graph, storage service, or data catalog? It's a data catalog. Who's in first place? Alexis. Alexis snuck up there. Okay. And the last question. Which organization provides near real-time data to monitor the weather, ocean, and space? ESDIS, NESDIS, or both? Okay. 27% of you got it right. It's kind of a quick a trick question, but okay. So Alexis is in first place. Yes, 5 people. Justin Rice is in second place. Leslie H. third. Chris fourth, and Valigator. Okay, that person is in fifth. All right. So pick up your swag in that order.
Yes. So while our winners are coming and picking their prizes, if I could get our panelists to assemble up here, and we'll go ahead and get our moderator set up, and we'll coordinate all of that in the meantime. Thank y'all.
All right. My name is Evan McQuinn. I'm a colleague of Inger and Angela and the NESDIS folks here, but for the purposes of this discussion, I'm a neutral third party moderating a panel discussion where we build community, right? Okay. Yeah, so I've got some, actually, first of all, let's go down the row here since there are some new faces and maybe just introduce ourselves, the panelists here. Do we have 2 mics? Great.
All right, I'm Justin Rice. I am the ESDIS Deputy Project Manager working right under Chris. This is my 10th year in ESDIS. When I first learned about NESDIS, I thought somebody was playing a joke on me. I'm like, are you for real? Ken Casey has always been a fixture, and I always ask him where he is this time around. So, but it's a pleasure to always be here. You're the virtual Ken Casey. All right, John.
Okay, I'm Sarah Lubkin. I'm the Science Data Operations Lead at ESDIS, which means I work with all the DACs and focus on science enabling. And I've been at ESDIS for 5 years. Before that, I was at our ESDIS, which is our headquarters program. And I work with them.
And I'm again GM Villamil Otero for NESDIS OCS, working with mostly with transition to operations. I've been with NESDIS as a contractor for 3 years and as a Fed for 3 years. So total 6.
So I'm Dean Carter. I am a physical scientist data officer with NCI. I've been with NOAA since 2011, and I was in the Air Force 23 years before that.
All right. So I've got some, starter questions to get us going. Also, I think, let's use the Slido. I've got that up here. I see some people are having some fun in here, talking about why doesn't NASA have turtles with radio backpacks? Some people replying that it's okay because they have grad students, basically. The most popular question is, why is NOAA so much better than NASA? I don't know what that says, but maybe to start off, honestly, with one of these questions from the audience is to maybe clear up, what the difference is. Do we really need these two separate agencies? Sounds like a duplicate.
You want to take it? Start.
Yes. I mean, we need both of them. I mean, there's from a 30,000 level feet view, it does seem like there's a lot of duplication, but I think Chris covered it. And then it was also a question that bears repeating. Real-time operations is a NOAA mandate, right? NASA does not touch that. That's not our mandate at all. Also, when it comes to our users' communities are slightly different. Again, you're talking about operations, and NOAA focuses on, like Chris said, right now and moving forward, real time and moving forward, whereas NASA focuses on, if there's an issue, we're redoing the whole algorithm and the whole process. We're reprocessing the whole mission. And so, whereas there from a 30,000 foot level, there is a lot of similarities. I think we're working to understand them more, and behind the scenes, figure out how to do a better job of bridging those gaps. One of the questions talked about CMR. That's one of the that's a repository that we came up with as this, and through a lot of these interactions, through forums like this, ESIP, we formed a collaboration to have that open source tool adopted by NESDIS, and it's been going well. And we need to figure out how to, in the future, work together to develop the next iteration of CMR. To be honest, right now we have 2.4 billion granules, and it's okay for right now, but going forward, we know we need to rapidly evolve CMR and not do that alone, ideally. So we need both of them. Although this does feel like a cage match. I mean, let's be honest.
So I actually had a conversation with a user needs person at NESDIS recently, Vanessa, if anybody knows her. I was talking about what our user needs were, and she was like, well, that's totally different than what we consider user needs. We work with agencies. We work with the National Weather Service. We work with individuals. We work with people who are at different companies, agencies, decision makers, as well as the science community, which is one of the reasons why it's important when we have a change in our data to go back and fix it, because a lot of scientific studies are looking at something over time and how it's changing rather than, and then forecasting from that into the future. But we're not looking at the weather forecast for tomorrow or next week. So I think that's a big difference.
And I want to add that pretty much we're complementary, right? Because as they have mentioned, they are looking at reprocessing the data, right? For scientists to look at that reprocessed data. Well, those scientists are developing the algorithms that, well, we help transition to operations. So it's complementary. We, rather than having a single organization having to deal with so much overhead of like dealing with the entire thing, I think it's a good division of labor. I would say it's complementary. You want anything to add?
Sure. I'll say that when I joined the NOAA archive, and I first became aware of the NASA DAX, I kind of wondered the same thing. It seems like a little redundant, but I realize now that we have different missions, and just like going back, NASA has this distinct mission. And looking back to NOAA's mission, it's operational. It's looking forward, and on that slide, I think it was my first slide, where we had those various sectors like with the insurance companies and things like that. I don't think NASA really is in the business to answer a lawyer's question about the weather on the day of an accident 20 years ago. That's a kind of a NOAA thing. So I think they are distinct.
So I'll bounce back and forth between some questions that we wrote ahead of time, and then I see that some good questions are coming in from the audience as well. So that's great. Something that's been kind of near and dear to my heart, having come to ESIP and AGU and AMS for years and years, is we hear this story about we've got to improve interoperability. We've got to improve harmonization. And I'm curious from your guys' perspective, what do you think has been our biggest impediment to actually achieving interoperability?
Yeah, I'll start. For me, one of the biggest roadblocks, I would say, is that it's funny because the first question was about why do we need both? Because for me, one of the roadblocks is that at least inside NOAA, we have different line offices, right? We have the National Weather Service, we have OAR, and each of them have a different mission, a different objectives that they want to accomplish, and they may do it in different ways. So, but what ends up happening is that we may, working towards the same mission, we drift separately, and then we run into the issue of interoperability because there's no, I would say there's no connection, and we're working towards that, right? We're working towards making sure that's what the NCCF is for. That's why we're trying to establish governance towards that. But as of right now, I feel like that is the biggest roadblock, that we having the organization having different missions makes it so that we have our different standards, different formats. Like on my just to provide an example, we generate the products in NESDIS and we give them to the user. One of the users is the National Weather Service, and they use AWIPS. Well, we need to reformat the product to make sure that they're using it in AWIPS compliant. Another type of data, buffer. So it's a lot of different formats. So it feels like we are always having to. Well, obviously, we're in the service of helping the customer, of making sure that they have the data in the way that they need. But we need to get to the point where we can start working together to have the data in same type of metadata or same type of format, like reduce the complexity that we have with so many different types of format going around. That's my opinion.
You want me to go first?
Sure.
So we've had for we have working groups, or in the past, we have had working groups that work on different issues. The longest running working group for ESDS was the data interoperability working group. I think it may have gone on for 20 years. Maybe I think some people on that working group are in this room. So, but we did wrap that up without achieving data interoperability. I think one of the big challenges is that people are doing this in their spare time because operations are important. People are accessing the data. We are doing our best to keep up with the work that has to happen day to day, and it becomes a volunteer effort, and it becomes something that people are doing in their spare time, and there's not a lot of it. One thing we just did at ESDIS is stand up a data governance board. That is one of the things they have put as a priority to look into. We'll see if having a data governance board where people are committed to this issue and have decided to dedicate, I think it's 20% of their time to the data governance board, if having dedicated time to work on these issues actually makes a difference. So we hope so.
Oh, that's a hard topic. It's very hard. I mean, interoperable standards is an ideal that we all wish we could get right. But the problem is it's hard and it's expensive and it changes a lot depending on what standard you're talking about. And when you have a large organization such as ESDIS, and I'm sure NESDIS, it's really, really hard to get all of your archive compliant with any particular standard. And it could be expensive. So who's to say once we move to XYZ standard that's interoperable today, it takes us 10 years to do it, that by year 5, it's already outdated. And so while we are aware and we know this is a problem, sometimes we're slow to move because we're kind of trying to be clued into the community, the broader community, not just NASA, not just NOAA, to see where the trends are. Is this a long-standing thing? How can we help drive the conversation of where we want to go and influence where the community goes? And I think we can do a better job of doing that in particular versus being somewhat reactive and tentative. We can put a little bit more investment in driving those standards and being in the driver's seat and helping influencing those decisions and making sure that those standards are here to stay whenever they are brought into the scene. I think we do a better job at that.
So there's a lot of questions in the Slido and also in what we had been thinking about before about the cloud, right? So maybe there's a series there. What do you think has been the single biggest bottleneck for migration to the cloud?
Users or organization?
I think for your organization, each one.
I need to think.
Here's somebody.
Oh wow! Hot potato? No. Well, I guess I'll start. I think for NESDIS, at least in my point of view, is the amount of data that we're trying to bring into one location. And not only the data, is the resources, right? Because the data doesn't just come in willy-nilly, right? There has to be someone setting the pipelines, whether it's S3 bucket to S3 bucket, FTP, like whatever way the data needs to be brought in, there is someone doing the manual work to set up that pipeline. And I think it is the amount of resources that we need in order to be able to do that with the amount of data that we're trying to get available to the user. Right now, we're trying to migrate all of the NCEI's data into the NCCF. We're trying to get data from UMETSAT, and at the same time that we're migrating data, we also have to support new missions. New satellites are always launching. We have the CDP, that is new commercial satellites. So it's a never-ending flow of data. We'll get there eventually, but that is, in my opinion, the roadblock, is that we have limited amount of resources setting this up.
I'm not very high up in my organization, but at my level, I think with the cloud migration, I think the biggest thing is the organizational change that's associated with it, and also the change in process that many people, many scientists and IT folks are very used to doing things in a certain way, and change can be hard, I think. And I think that's the toughest part. It's the people part, maybe, not maybe the technology.
So I actually had a conversation with this earlier with one of the DACs, and they said that the hardest thing, what's keeping them from being at 100%, is that you have this data coming in and you want the data to come directly to the cloud, but it's from a data provider that's been providing data for a very long time in a certain way. And they don't have the personnel or the funding to change how they're doing it. And so they need our help, and it's a lot of work.
I like your answer. All your answers. I mean, let's be honest. I mean, we've been moving data for a very long time to get to the cloud. I would say about at least 8 years of moving data. We've been talking about data movement for a very, very, very long time. And this year, hopefully, we will finally stop talking about moving data because we'll be done. Isn't that right, Doug? Yes, we'll be done. He said, Doug says yes. Doug says yes. So moving... What I just said. I heard yes. I don't know what happened between what you said and what I heard. We will be done. I will not be here next year saying this, that we are not done moving data. All right. So I mean, yeah. So I like the idea of it's the culture, changing the culture both within the organization as well as bringing the users along with us is one of the biggest pieces, and that's why we came to OpenScapes and said, help us. We need help with a lot of misconceptions surrounding the cloud, especially with our users. Will I be charged? The answer is, it depends, right? And we don't like to say that, but the real answer is, it depends on how you use the cloud. But if you just want to download data, obviously it'll be free. But since there's some nuance in that answer, you have to be very careful on how you communicate those nuances to the user, because the first thing they think is, I have to give Amazon, this big company, my credit card, and this is not how I'm used to doing business. And they're just all they want to do is make money and take all my money, right? And so... And so we really have to be careful about how we communicate these things and take the users along with us on this journey. And I think we've through OpenScapes have done a great job at that, as well as working with our different data centers, our DACs, to get all the data moved from on-premises to the cloud. It took us 30 years to get to where we were with all these on-premises systems. I guess 8 years isn't so bad, but I won't be here next year talking about we're moving data. That'll be done with. Doug said it. You heard it. We won't be doing this anymore.
Nobody actually look at Doug. That's so on that topic of storage, we have a couple of related questions. Are there plans for the agencies to work more closely to streamline storage locations of data? Some data gets stored within both NASA and NOAA collections, and search across both of the agencies' data sets as a combined collection. As kind of a follow-on, there's another question here. NOAA has a cloud and NASA has a cloud. Would it be more practical to have a federal agency cloud where all federal agencies put their data in the cloud?
In my dream where all these things sound like great ideas, I would love to have all cloud. Everybody has a cloud that just mashes up together and this stuff just magically works. But, in reality, it's not quite like that. Responding to one of your questions about, duplicate data in different places, I'm glad that you mentioned that because FDP is something that we're spinning up, the foundational data products. We're going to be looking across some of the products that we have been generating and saying, maybe it's not, maybe this should belong somewhere else. Maybe this is not the best fit for NASA to continue to process and put out there. When it comes to combining repositories, I like the idea. Just hadn't run across a good idea on how to do that really well. If we were able to come up with a great idea about that, I'm all for it. I don't like the idea of these, our users being able to just come to, our CMR and that's all they can find out is about our data. However, I do feel like AI is going to change all of this for us. We don't really have to worry about it as much if we can both expose our archives to these different LLMs, for instance, and then it can just tell the users, hey, here's where the data is. Here it is, right? So I want to get out of the business of creating, artificial boundaries and barriers. If AI can fix it, let AI fix it.
Sure, I'll just simply say it's NOAA's policy not to archive a data set that's archived somewhere else. Occasionally it happens, but what it does, it creates issues of data stewardship, two agencies stewarding a single data set. That's something we want to avoid. On the subject of combining or having one massive cloud for the federal government, we could barely do it just for ourselves. How is that going to work? I don't know. So,
and I want to add to that because yes, it would be great to have data interconnection. Like, I mean, that would be great. Like a data lake or something where we can all get access. And oh my God, it would be amazing if from our side in the NCCF, we search for data and it gives us the link to the NASA's data, like not necessarily download it from the NCCF. You can go, like, gives you the link to NASA's website or vice versa. I think that is definitely something that as we continue to working together, we can hopefully get to that point in the not so long future. And maybe, as you said, maybe AI, it's going to get us there. So excited about the future.
And now I'm getting a spam call. Let's get rid of that.
Do not take it.
Yay, AI. Yeah. So there's a variety of questions in here, I think, that touch on, or maybe are follow-ups to some of the things that you've said already. So for example, how do you envision combining efforts to improve and standardize services going forward to reduce complexity to the user community? And even specifically, when you said we need to be driving standards, will that equate to prioritizing OGC involvement versus best effort?
Yes. You want to take it?
Yes, OGC, absolutely. We participate, but we're not active as I want to be when it comes to OGC participation. I think we need to dedicate more cycles to the future. And as Chris mentioned, it's going through a lot of changes right now. And oftentimes that takes a lot of your bandwidth, a lot of your cycles. We need to spend a little of those cycles looking towards the not so present, right? 5 years out, 10 years out, working with OGC and the broader community to find where we should be and keep the eye there. It's just, you mentioned something else that I wanted to speak to, but My brain does not retain as much information as it used to.
What was the first? Oh, open source tooling maybe is no. They keep shifting around on me. But in general, you know, I think there's a number of questions in here about driving standards, driving open source involvement, driving shared tooling,
shared tooling,
opportunities,
shared tooling. Somebody mentioned it down here. It's hard enough to get our own house in order. Do you know how hard this is within our own house? This is very hard. It's very hard to get our own house together. And when that magical day comes, I feel like MLK up here. When that magical day comes, we get our house together. We can then reach across the aisle to our brothers, NESDIS, brothers and sister organizations, and we can jointly get our house in order. But until that day comes, we have to get our own house in order. Right now, we're working on it. Right? We're working. I do have a dream, though, that one day.
But I think continued participation in ESIP and OGC while we're doing that is one way to communicate how we're getting our house in order and perhaps share with NOAA and see that we're kind of working in the same direction.
And we are also getting our house in order. So both our houses are getting in order. And when that time comes, I mean, we're always communicating. We're collaborating all the time. And ESIP is an amazing place to do that. So we'll get there. We'll get to the point where we can look at each other, learn from one another, how we got our house in order, how they got their house in order, and maybe we can build an annex to the house, and that one might have an underground tunnel connecting to each other's houses, and we can, so we'll get there. We need to first get our house in order, and we're working towards that, and then we'll see what we can do. But as has been mentioned, ESIP is the perfect place to talk about it and see where we stand, what progress has been made, what needs to be done, and learn from one another. And not only from us and like NESDIS and NESDIS, from all the other communities, all the other users that agencies, partners that have also been doing this. We can learn from one another.
I can't answer that.
I think maybe related to this in terms of how we might actually accomplish, working together. There's a question here that says, Neil Jacobs pushed hard at NOAA for common community development for modeling with funding. Could we encourage these two agencies to truly fund community common development in addressing the challenges of both agencies? Could SBIRs, STTRs, grants, or other vehicles be used to fund these initiatives?
That is a little bit above my pay grade, in my opinion. I just started 3 years ago at the SAFED employee, so I think a big issue is, as the question implied, is the funding. Funding is way above our heads, and NESDIS, NOAA, and NASA gets their funding completely separate. So this is something that, at least on my side, we can say that we talk to. We promote and we say, hey, the users are asking for this. We need to make sure that it gets funded, and then cross our fingers and see what they agree to fund. So something is working, because the users talk to us. We talk to people that control or that has the money. So there is a pathway towards that. We just need to hear more from users, hear more from the people that are using the data as to why it's important, so that we can continue or try to get funding to the things that we all know matters or that we want to see in operations or we want to see other people using. So I think what I'll end with me saying is that I think communication is key. And just keep screaming through the rooftops. This is what we need, and someone will listen. Someone will listen and help get it across the finish line.
You know,
we're running short on time.
All right. So what I'll say is this, collaboration across agencies is harder than you think. I told you that we had CMR. You know how long it took to get that thing across, just to start the collaboration, just to have an MOU. It took like a year and a half before they got approved. It goes all the way up to headquarters, and then the lawyers get involved. So while I do love collaboration, you would be surprised, or maybe not, how bureaucratic the government actually is, even if you want to do something super awesome. I'll leave it at that. Next question.
All right. Well, there's a lot more great questions in here, but we're at the end of our time for the session. I guess the last thing, maybe this is something to go forward with into the break. Last question. Who's better at dancing, NESDIS or ESDIS?
You should have been at the two-step, which I was not last night. We would have probably found out. There was a two-step situation last night.
I say ESDIS.
I say NESDIS.
As long as you're doing it, Gian, I volunteer you.
I have a twin brother. He will be the one dancing, and as far as everyone's concerned, that's me.
Yeah, counts as double time, right? All right. I'd like to thank everybody for coming. Make sure you pick up some more swag, please. I'd like to thank our presenters. Please stick around for a few minutes afterwards. We have special gifts for you. Actually, you probably should just put that umbrella back or give it to somebody else. I have another one for you. Yeah, throw it out like it's Mardi Gras. Don't hurt anybody. We're not liable for that. I don't take lawsuits or anything. And thank you to our program offices who gave us this swag too. Also, if you have not gone into the notes document, I have done my best to capture all of the Q&A questions from the Slido, especially those we didn't address. If you have other questions, you're welcome to add them to the notes document. We'll try to go back later and make sure that we address those. And if we can't get to them, incorporate those in future ESIP briefings so that we get more sessions like this where we can really reach out and have these kind of interactive sessions, especially fun ones. I like fun ones. Why don't we have more fun ones? So, all right. Thank y'all.